Hi friends, in this video we're going to do a small IoT project and control an LED with a Flask web server hosted on Raspberry Pi. Since we are using Raspberry Pi 0W, you can wirelessly connect to the Flask server and wirelessly operate an LED bulb. In the end, the result would be something like this. We will use a web page to control an LED through a Raspberry Pi. A Raspberry Pi is a single board computer and it also has GPIO pins, which is general purpose input output pins. These are the pins of the Raspberry Pi 0W, and there are some GPIO pins, which is general purpose input output pins. So the operating system can set the voltage of the GPIO pins programmatically. And there is also a module called RPi, using which you can control the voltage of GPIO pins from Python scripts. And we are going to exploit that in this project. So this is the pin layout. There is this GPIO 18 pin and the ground pin, and we are going to use these two pins and connect them to an LED and control the voltage of this GPIO 18 pin to on or off the LED. You can use any GPIO pin, but for this video I am using this GPIO 18 pin. So our circuit is going to be something like this. We will take an LED, and an LED has two leads. One is a longer lead and one is a shorter lead. The longer lead should be given positive voltage and the shorter lead should be given less voltage of the ground voltage. So the positive lead of the LED is being given to GPIO 18 and the smaller lead is given to the ground. And notice that we are using a 1 kilo ohm resistor without directly connecting the shorter lead to the ground, because the resistor helps in limiting the current passing through the LED, thereby protecting the LED and the Raspberry Pi. So this is a really simple circuit. Connect the output to an LED, that's all. So how are we going to implement this circuit? Soldering the LED with the GPIO pins doesn't seem like a good idea. So what we can do is, we can use a mini breadboard or a breadboard, and we can connect the elements through the breadboard and jumper wires. So the schematic would be something like this. The positive lead of the LED is being connected to GPIO 18 but through the breadboard. So the positive lead of the LED will be inserted into the breadboard and a jumper wire would be taken from the breadboard to GPIO 18. The same way, the shorter lead of the LED would be inserted into the breadboard and the resistor would be connected through the breadboard to the LED, and then the other end of the resistor would be inserted in the breadboard and the jumper wire would be taken from the breadboard to the ground. So we are using breadboard and jumper wires to easily connect the Raspberry Pi, LED and the resistor. If you don't know how breadboard works, it's really simple. All these horizontal holes are connected. So if you keep these 2 points in this horizontal line, that means these 2 points would be connected. So this is how you can create connections on a breadboard. So this is all the items we want to implement this project. We have a breadboard, 2 jumper wires, resistor and an LED. Using those, we can implement this circuit. Before implementing the web server based user interface to control the LED, let's try to start with a simple project where we will blink the LED indefinitely. So let's try to do that first, and then let's try to use that knowledge to implement the web server where you can control the LED using the web page. So I'm going to take a blank folder and I'm going to open it with VS Code. Let's try to create a new Python file and name it led.py. And after writing this Python file, we will deploy it in our Raspberry Pi. So in Raspberry Pi, we will have a RPi module which can be used to control the GPIO pins voltage in our Python scripts. So I'm going to import rpi.gpio as GPIO. Since we are controlling the GPIO 18 pin, I'm going to write LED GPIO pin equal to 18. And then you're going to set the GPIO mode as BCM. So this is the layout we are using to locate the pins on the Raspberry Pi's pin layout. And then I'm going to say GPIO.setup LED GPIO pin or the pin 18 as the output pin. So we are configuring the GPIO pin as the output pin. And now if you want to switch on the LED, you can just write GPIO.output, the number of the pin which is 18 or LED GPIO pin, and then set the voltage to GPIO.high. But to blink the LED, you need to keep the voltage high and low with some interval. Let's try to make the LED to blink with 1 second periodicity. So let's try to abstract out some variables here. So I'm going to say out voltage equal to GPIO.high. So replace this with the variable out voltage. And then let's try to implement an infinite loop with while. So I'm going to write while true. And let's try to create a variable which will indicate whether the LED is on or not. So I'm going to write is LED on true. So the out voltage will depend on this variable. So I'm going to write out voltage equal to GPIO.high if LED is on or this variable is true, else it would be low. And then I'm going to say GPIO.output, the out voltage. Let's try to print the status of LED in the command line also. And now before running the next while loop, you have to wait for some time. So I'm going to import time here. So I'm going to write import time, and then I'm going to write time dot sleep 1. That means this code will be waiting for 1 second and then going to the next step. But hey, I did not still change the LED on status. So I'm going to write is LED on equal to not is LED on. That means if it is true, it will become false, and if it's false, it will become true. So that's it. Using this Python code, you can infinitely blink an LED on the Raspberry Pi pin 18. Alright, let's try to connect to Raspberry Pi and deploy this code and run this Python code to see if the LED is blinking on the Raspberry Pi. So if you don't know how to set up a Raspberry Pi 0W or a Raspberry Pi in general and run Python on it, I've already made a blog post on it with all the images, notes, source code, commands, etc. So please check out that blog post in the description of this video if you don't know how to set up Raspberry Pi. I've also made a video on that. Please check out the link of that video in the description. Alright, our code is ready. Let's try to connect to Raspberry Pi and deploy this code. So I'm going to open a command prompt and I'm going to connect to my Raspberry Pi. So I'm going to write SSH, the username of the Raspberry Pi, @ the host name of the Raspberry Pi. So the username is raspcpu and the host name is awesomepi.local. You can even give the IP address here. So I'm going to go ahead and enter, and it's asking the password. I'm going to type the password, and now I'm connected to my Raspberry Pi. Let's try to do ls-l and see what are the files. Currently we don't have any files in the Raspberry Pi. Let's try to create a new file. I'm going to write touch led.py and ls. Now we got led.py. And let's try to edit this led.py. So I'm going to write nano led.py. So let's try to copy and paste the code which we have written. Let's try to Ctrl A, Ctrl C and paste it here. And we got our code here. Let's try to save it. Ctrl X. Yes. Enter. And now let's try to see what is there in led.py. So I'm going to write cat led.py. So we got our Python code here. Alright, let's try to clear the screen. And now let's try to run the Python code. So I'm going to write python3 led.py, and yeah, our code is running and the LED is blinking, and we can see true false because the LED state is being changed. Alright, let's try to exit the Raspberry Pi now. So hey, we have successfully written a Python code to control the LED status through GPIO pins. With this knowledge, let's try to create a utility function that can be used by the Flask server to control the LED. So let's create a new file. I'll just name it pyutils.py. So hey, this is our function set LED state, which you can call to set the status of the LED. If you pass true, it will switch on the LED, and if you pass false, it will switch off the LED. So it's achieved just by using gpio.output, the LED pin which is 18, and the voltage which is decided by the boolean value here. That's all. And before declaring the function, we are initializing the pins. So we said set mode as BCM and set up the LED pin as an output pin. That's all. Alright, we got our function which can be used in our Flask server now. Let's try to create our Flask server. So I'm going to create a new file and I'll name it server.py. And this is a very simple Flask server which will run on port 5000. If you go to the root URL, you should get a page called home.html. Let's try to create this home.html page now. So I'm going to create a new folder. I'll just name it templates. And now let's try to create home.html here. So I'll write home.html. So let's try to create a small HTML template here. And here we have given two buttons, which is turn on and turn off. So when the user opens the root URL of this Flask server, he will be presented with this web page, and it has two buttons, turn on and turn off. Currently these buttons don't do anything, but we will change that later on. So that's it. The Flask server layout is ready. Let's try to run this Flask server in this computer first. So let's try to run this Flask server. Hey, I got an error that no module named rpy, because in Windows you don't have this rpy Python module. So how can I test this code which contains the rpy module in my desktop? We can cheat a little. If you get an error while importing this GPIO module, let's try to use a dummy function instead of this real function which actually controls the GPIO pins of the Raspberry Pi. So this is the new source code. I am first trying if I can able to import the GPIO module. In Windows, obviously this would give an error. I'll just declare a flag that rpy is not present, and by default I will create a variable called setLEDState and assign it to a function which is actually a dummy LED controlling function, it will just print that LED state is changed, but there is no LED actually in the Windows computer. But if the rpi is present, you define a function set pi LED state, and you will set the set LED state variable to this original function. So that means if you are trying to run this program in your computer, this function will be called, and if you are running the same program in the Raspberry Pi, this function will be called. So the advantage of using this setup is basically you can test your Flask server user interface before deploying it into Raspberry Pi. So still we are exporting this set LED state to the server.py, and this time it should work. So let's try to save this and let's try to run server.py, and we are able to run our server. Let's go to localhost port 5000, and that's it. We got our web page. Let's try to zoom in a little bit, and we got two buttons, turn on and turn off. And if you click this should control the LED connected to the Raspberry Pi. Currently it doesn't work because we did not do anything. We have just displayed a web page from our Flask server. Alright, let's go to a web page and let's try to create that functionality. So the strategy is basically if you click the button, we will create a button listener, and it will send a signal to the Raspberry Pi Flask server, and that Flask server will control the LED. So that's the strategy we are going to do. So let's try to create the button on click listener first. So we have assigned two listeners, on LED on and on LED off, for the two buttons. So let's try to define those listeners here. So below the body I can create a script tag, and in this script tag I have defined the two functions on LED on and on LED off, and these two will call a function called set LED state. For the on button you will set it as true, and for the off button you will give the input to the function as false. So the set LED state function needs to be implemented. So what we're going to do is we will send a post request to our Raspberry Pi Flask server along with the state which we want to set to the LED. So to create an Ajax post request to the server, you can use jQuery or use the fetch API. So currently, instead of using third-party libraries, I am trying to use the fetch API present in the modern browsers. So that requires async here. So I'm going to write async, and let's try to implement the function. So I have to do a post request to the server endpoint. We will create the endpoint later on, but let's try to define the function here. So the API endpoint which you need to create at the server should be something like this. It should listen for post request at the URL /LED/1 or /0. If it is /1, it should switch on the LED. If the URL is /0, it should switch off the LED. And it should listen for post request at this URL. Currently I am sending only 1, but this is wrong. You need to set the 1 or 0 as per this variable, which is the input variable isLED on. If isLED on is true, this URL should be 1, and isLED on is false, this should be 0. So let's try to keep that conditional statement here. So instead of keeping it a hard-coded value, I will substitute a variable here. So LED plus, I'm going to use this ternary operator. That means if it is true, this value will go, which is 1, and if it's false, this value will go, which is 0. So I'm doing a post request to the /LED/endpoint of the Flask server, which we need to implement. We will implement that later. And if the server sends a successful response, then it's good. If the server sends an error, we can even notify the user. So if the fetch response is not okay, you can give a small alert that command was not executed by the Raspberry Pi. And that's it, guys. We have created an on-click listener, and that on-click listener will call a function called set LED state in the JavaScript. And what it does is basically it will call a post request to the /LED endpoint, which we need to implement in the Flask server. So that's it. Let's try to save this HTML, and let's try to implement this /LED API endpoint. So I'm in the server.py. Let's try to create a new route here. I'm going to copy this and paste it here. Let's make the route /LED/int, and it will be something like state. So a variable called state will be created from the route. Let's try to rename it as set LED, and obviously we're going to give this variable state. So the state would be populated from the route, and obviously we should listen for post request. So I'm going to write methods equal to post, and now instead of rendering the template, let's try to use the utility function set LED state in this function. So if state equal to 0, we can switch off the LED. So I'm going to write set LED state as false, else if state equal to 1, I can set the LED state as true. So I'll switch on the LED. And if you get some other values other than 0 or 1, that means it's an invalid input. Let's try to throw the error to the API endpoint. So I'm going to write else, return a message something like unknown LED state, and the response code would be 400, which is error response code. So if the inputs are okay, you also need to send a success response, right? So I'm going to write return. You don't need to send a message. You can just send a status code called 204, which is successful. And that's all. We have implemented the API endpoint of the Flask server. Based upon the route provided, which is the state variable, which is 0 or 1, you will set the LED state. We have implemented the API endpoint, and also we have implemented the button callbacks to call the API endpoint in HTML. So let's try to save this, and let's try to go to server.py. Let's try to save this also, and let's try to run the server. Let's try to reload the web page. It's loading. Let's try to click turn on, and you did not get any alert message that the command was not executed. That means it should be running. And even if you see the command prompt here, setting dummy LED state as true, and if I click turn off, setting dummy LED state as false. Let's try to click turn on again, and you can see setting dummy LED state as true. So till now we are able to verify that on clicking the button is sending a post request to the API endpoint, and the server is able to respond to the API endpoints with appropriate outputs. Obviously, since it's a Windows machine, you're not able to directly control the LED here, but let's try to deploy this code in Raspberry Pi and see whether we are able to achieve this functionality through the web page. And hey, before deploying the code, let's try to do some styling here. I'm going to give a class called on button to this turn on button, and I'm going to give a class called off button to this turn off button. And now in the style tag, I will define the styles of these buttons. It's basically pretty simple. I've just increased the size and changed the colors of on button to green and off button to red. And if you click on the on button, you will see some darker hues so that you will know that you have clicked the button. So it's some basic styling. You don't need to understand this a lot. You can just copy paste this. So let's try to save this, and let's try to run the server again. Let's try to reload the page now. You can see the styling of the buttons is changed. Now let's try to deploy this code to the Raspberry Pi. You can use the command line to transfer these files, or you can use a GUI like WinSCP to transfer these files to the Raspberry Pi. Since I'm transferring multiple files, I think WinSCP should be convenient. So let's try to open WinSCP. So if you don't know how to use WinSCP to transfer files to Raspberry Pi, I've already made the video on setting up Raspberry Pi, and this is covered in that video. So check out that video in the description. So if you want to know how to set up WinSCP to connect to Raspberry Pi. So I'm going to create a new session in my WinSCP, and I'm connecting to the Raspberry Pi host, which is raspcpu@awesomepie, login, and then writing the password. So I'm able to see the Raspberry Pi file system in WinSCP, and I opened my required folder in the left side, and I'm going to just grab all these files which I've developed just now in VS Code and just drag them here. Let's try to replace the file, and that's all. I've deployed all my code to the Raspberry Pi. Now let's try to close WinSCP since we have sent the files to Raspberry Pi. And now let's try to open the Raspberry Pi through command prompt, and let's try to run the server in the Raspberry Pi. So I'm going to write SSH username, which is raspcpu, @hostname, which is awesomepie.local, and the password. Now I'm connected to the Raspberry Pi. Now let's try to see the files. We already deployed our code server.py, templates, pyutils in the Raspberry Pi. So let's try to run the server.py. So I'm going to write python 3 server.py. You can see the server is running. It's running on this IP address. You can use this IP address in the browser of any device in the same Wi-Fi connection, or you can even just use the host name, which is awesomepie. So in a new tab, I'm going to open awesomepie:5000. I can even use the IP address of the Raspberry Pi as shown in this command prompt. So let's go to the Raspberry Pi web page at this URL. So I'm opening the Raspberry Pi's web page here. It's not the web page served from my computer. So this way, using any device which is mobile phone or laptop or whatever which has a browser in the same Wi-Fi as the Raspberry Pi, you can access this page and you can turn on or turn off the LED. The output would look something like this. We are accessing the web page from the Raspberry Pi, and we are controlling the LED through the web page served by the Flask server in the Raspberry Pi. So that's it, guys. In very less lines of code, you are able to implement an IoT project to control an LED using Raspberry Pi and Python Flask server. You can run the Python server in the background using the nohub command, something like this. This way, even if you come out of your terminal, the server will not be stopped. it will be running as a background service in the Raspberry Pi. And if you want to kill the server, you can just use psaux and grep the command of the server and then kill the process. You can see I've created a blog post on how to control an LED with Flask server hosted on a Raspberry Pi. I've given you the diagrams, layouts, code, so that you can copy paste and practice it in your own computer and Raspberry Pi. I've also given the references to the official documentation so that you can do further reading. Please ask questions or post your valuable feedback in the comment section. Hope you like this video, guys. Thank you for watching. Peace.